and special angles. Okay, we're gonna be doing this today. So we're gonna after this lesson, you have to be able to recall all three trigonometric ratio. Okay, and then you also have to know how to determine the values of trigonometric ratio for special angles. You also should be able to apply the SOHCAHTOA to solve right angle triangle. So we're going to talk about SOHCAHTOA. And then you also have to be able to use the calculator correctly in degree mode. So your calculator should be in a degree mode, okay? There on top supposed to be D sharp. So before we do this, you should already know Pythagoras theorem, right? You all know Pythagoras theorem. You also know some properties of right angle triangles, right? And then you also know the basic algebra. So we're gonna start with a quick activity. So let's say they say calculate without a calculator. Okay, without a calculator, and then you are given that number one, it's 3 squared. Okay, it's 3 squared plus 4 squared. Okay, and then they say find the hypotenuse of a triangle with 5 centimeter. Sorry, before that. So I want you guys to calculate without a calculator here. How are you going to calculate this without a calculator? 3 squared plus 4 squared.
I think we're gonna find what is 3 squared, which is 9.
Yes.
Then we're gonna say 4 squared, which is 16. And then which is 25.
Yes. So that's right. This is how we're gonna get it without a calculator. And then lesson number 2, you are given a hypotenuse of a triangle with 5 centimeter and 12 centimeter. So here you're gonna find hypotenuse of a triangle. Okay, with 5 centimeter and 12 centimeter. So I want you guys to find a hypotenuse of a triangle with a 5 centimeter and a 12 centimeter. How are we going to get the hypotenuse?
We're going to use the theorem of Pythagoras.
Yes. So I'm going to use it.
5 squared plus 12 squared. Plus 44 plus 69.
We are looking for hypotenuse.
If I did my calculations correctly, my answer is 18.
How did you get the 18? Remember, we are calculating without a calculator. Okay, it's fine. It's just hypotenuse. Remember, right? And okay.
Wait. Okay, yeah, it's fine. It's 13 centimeters.
Okay, our hypotenuse is 13 centimeter. It's fine. So name the longest side of a right angle triangle.
Hypotenuse.
Great. Okay, sharp. So moving forward, we're gonna start now. It was just a startup activity. So we're gonna start with the introduction. Trigonometric studies the relationship between the angles and sides of a triangle. Okay, so when we're talking about trigonometric, we're talking about the angles and the sides of a triangle. So in a right angle triangle, there are 3 important sides. Okay, we have the hypotenuse, we have the opposite, we also have adjacent. For sure you know this. So the three trigonometric ratio, let's say we have this right angle triangle. Here on right angle triangle, we have the hypotenuse. Let me write it in capital letters. We have hypotenuse, we have opposite, we have adjacent. Okay, these are three trigonometric ratio, three important sides of a right angle triangle. Hypotenuse is the opposite the right angle, the longest side. Okay, and then opposite is the given angle, is opposite the given angle, and adjacent is next to the given angle, not hypotenuse. You see, the adjacent is next to the angle. This is hypotenuse. And then we have three trigonometric ratio. So we have the sine, we have the cos, we have a tan. So I want you guys to know this, or to remember this trigonometric. We're gonna call them SOHCAHTOA. SOHCAHTOA, like this. So the it's for sine, opposite, and hypotenuse. Ka is for cos, adjacent, and hypotenuse. TOA, it's tan, opposite, and adjacent. Okay, so this one is gonna help you to remember the trigonometric ratio. SOHCAHTOA. So the it's sine theta. Okay, so sine theta is what? It's opposite over hypotenuse. And then we have ka, which is cos theta. Okay, which is adjacent over hypotenuse. And then we have TOA, which is tan theta, which is opposite over adjacent. So you have to remember these three trigonometric ratio, like SOHCAHTOA. Okay, so this is how we're gonna remember them. So now the memory trick is just so sine, it's opposite of hypotenuse, cos is adjacent of hypotenuse, and TOA is opposite of adjacent. So now we're gonna move forward, and then we will focus on what? On special angles. Okay, so we have special angles. So when we're talking about special angles, we're talking about 0 degree. We're also talking about 30 degree, 45, 60 degree, and then 90 degree. So these are special angles: 0, 30 degree, 45, 60, and 90. These are special angles. So we're gonna get the sine of 0, the cos of 0, the tan of 0. So we're gonna get all the angles here using trigonometric ratios: sine, cos, and tan. So we're gonna have the sine theta, and then we're gonna have this cos theta and tan theta. Okay, I think I should just write them here. Sorry. Let's say here we have 0 degree. Let me just rewrite this in order. Sorry about that. So we're going to have 0, 30, 45, 60, and then 90. 1, 2, 3, 4, 5. So we have 5 special angles. These are angles. Okay, and then we will find the sine theta. Gonna get cos theta, and then tan theta. Okay, so these are special angles. Okay, so if we put 0, so if we put 0 here on theta, it's gonna be sine 0. Sine 0 is what? It's 0. Okay, and then if we put 0 here at cos 0 is what? It's 1. And then tan 0 is what? It's 0. And then cos 30 degrees, so here it's just angles to show that they are angles. Sine 30 is what? It's 1 over 2. Okay, and then cos 30, it's square root of 3 over 2. Square root of 3 over 2. And then tan 30 is also square root of 3 over 2. Okay. And then sine 45. Sine 45 is square root of 2 over 2. Even cos 45 is what? Is square root of 2 over 2. Tan 45, it's 1. And then sine 60. Sine 60 is square root of 3 over 2. And then cos 60, it's what? It's 1 over 2. Tan 60 is square root of 3. Okay. And then sine 90. Sine 90, it's 1. Cos 90, it's 0. And then tan 90, it's undefined. Okay, so you guys, you should memorize this table. You have to memorize it. Okay, because we're going to use it a lot. When we're doing trigonometric, we're going to use this table, so you have to memorize it. Okay, so now let's do an example. Let's say sine 30. Sine 30, we know it's half. And then cos 60. Cos 60 is also half. So you just have to memorize this table, okay, and then know, okay, if I'm given sine 30, sine 30 is half. If I'm given sine 45, sine 45 is square root of 2 over 2. So because they will tell you not to use a calculator. Most of the time they'll tell you not to use a calculator when you are doing what? Trigonometric. When you're doing trigonometric. So let's do an example. Moving forward, we're gonna do an example. In this example, let's say you are given a right angle triangle. Given a right angled triangle. Okay. Where the opposite is equals to 10 centimeter. And then they say, okay, find sine theta. Okay, they want you to find sine theta, and then you're also given hypotenuse, which is, no, the hypotenuse is 10 centimeter, and then this one is 6 centimeter. Okay, so I want you guys to find sine theta from the given information and then give me the answer. I'm giving you 2 minutes. Dowd. Spiel.
Copy.
Yes, I'm giving you 2 minutes to do this example. We are given a right angle triangle where opposite is 6 centimeter, hypotenuse is 10 centimeter, and I want you guys to find sine theta. Guys, are you still here?
Yes, I could have writing.
Okay, I thought you didn't hear me.
No, we did. It's 3 centimeters. Ah, no, it's not 3. It's not 3. It's 3 over 5.
3 over 5. So we're given a right angle triangle with opposite of 6 centimeter and hypotenuse of 10. And then they say we are looking for what? For sine. And then we know that sine is what? It's opposite over hypotenuse. So it's going to be 6 over 10. And then when we simplify, it's going to be 3 over 5. Okay. Moving forward, let's do another example. So example number 2, we are given adjacent. which is 8 centimeter, and then we have hypotenuse, which is 10 centimeters. So Chipiwa, I want you to find cos theta.
Okay. Sorry. Over 5.
Okay, 4/5. So we have the right angle triangle, hypotenuse is 10, adjacent is 8, so it's gonna be 8/10, which is 4/5, like this. Okay, moving forward, let's do this one example. Let's say I want you to find the value of sine 45 degree plus cos 60 degree without a calculator, without the use of a calculator. Remember, I told you you should memorize this table. You should memorize this table, okay? You should know this table. Okay, sine 45 is, let me go back. It's sine 45 plus cos 60. So I want you guys to find the value of this. Guys, are you calculating?
Yes. Bobby, I got to a stage whereby. Wait.
Chipiwa, are you calculating? Are you finding the value?
Yes.
How much? What's the value?
What?
What's the value of sine 45 plus cos 60 degree?
One plus square root of 2 plus 1 all divided by 2.
Okay, and then we're gonna simplify from here. So we're gonna take out 2 as a common denominator, and then we have square root of 2 plus 1. So this is our value. Okay. I want you guys to do this quick quiz. So Chipiwa, please state the meaning.
State the meaning
of this before we move to the next lesson. What's the meaning of this? Sokato.
Into sine theta. So is sine theta and car is cos theta.
No, remember I said so it's a sine is equals to opposite over hypotenuse, right?
Yes.
Yes, so it's going to be opposite over hypotenuse.
Car is going to be adjacent over hypotenuse.
Yes. And then tor
is going to be opposite over adjacent.
Yes. So I just wanted you to state the meaning of that. And then doubt. That I want you to evaluate. It's just a quick quiz. I want you to evaluate cos 45 degree.
Cos 45 degrees is equals to the square root of 2 divided by 2.
Okay, great. Okay, so we're going to move to the next session where we're going to be doing reduction formula and the cast diagram. Okay, so we'll be doing reduction formula and the cast diagram. Okay, we'll be doing this. So at the end of this reduction formula and the cast diagram, you have to understand the 4 quadrants, and then you also have to be able to use the cast diagram to determine the sign of the trigonometric ratio. And you also are able to apply reduction formula, and you also have to evaluate trigonometric ratio for angles greater than 90 degrees. And then you also should be able to solve problems involving quadrilateral angles. And then you still remember the SOHCAHTOA. We're going to use that sine, cos, tan. Under trigonometric, those are the ratios that we're going to use. Sine, cos, and then tan. Sometimes we're going to also use the inverse of this. Not inverse. What do we call them? The opposite of sine, opposite of cos, and then opposite of tan. We're also gonna use those ones. And then the special angles, you still remember we have 0, 35, 45, 60, and 90. Those are our special angles. You should also know the unit circle basics. You should also be able to know angle measurements in degrees, because most of the time our angles, they're gonna be in degree Celsius. Degree. Sorry, they're gonna be in degree. And then now, to determine whether sine, cosine, and tangent are positive or negative, we're going to use what? Cast diagram. We will use cast diagram. Okay. Or before that, I want you to know that until now we have worked with angle between 0 and 90. So our special angles was 0 and 90 degree. Remember, it was 0, 30, 45, 60, and 90. So now we are going to use what? We're going to use angles starting from 120 degree, 135, 210, and 330. Remember, before this lesson we were using special angles 0 degree to 90 degrees. So now we're also gonna include 120 to what? To 330 degree to determine whether sine, cosine, and tangent are positive or negative. We're going to use what? A cast diagram. So whether to determine, sorry, to determine whether sine, cosine, and tangent are positive or negative, we use what? We're going to use the cast diagram. We're going to use that. So when we're talking about the cast diagram, we're talking about what do you call those four four quadrant. So we're going to have like this is the quadrant. So we're going to have the first, second quadrant, third, and the fourth. Okay, so the first quadrant, it's all positive. Okay, they are all positive. So first quadrant, everything here, it's positive. Everything, cos, sine, tan, they are all positive. And then here on the second quadrant, sine, it's positive only. It's positive only on the second quadrant. Okay, first quadrant, all cos, sine, and tangent, they are positive. And then on the second quadrant, sine, it's positive only. And then on the third quadrant, tangent, it's positive only. On the third one, tangent, it's positive only. Okay, and then on the fourth one, cosine here, it's positive only. Okay, so the first quadrant, all everything, cosine, sine, tangent, they're positive. Okay, they're all positive. Let me write this side. Here I was just showing you the quadrant. We have quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. Okay, so let me write this side. So the first quadrant, 1. I was saying that all are positive. Okay, and then quadrant 2, only sine is what? Is positive. And then quadrant 3, tangent, it's positive only. And then the last quadrant, only cosine, it's positive. Okay, and then you also have to know the signs of trigonometric ratio. The signs of trigonometric ratio. So I'm going to make a table here and show you the signs. Okay, sine, of trigonometric ratio. So on the first quadrant, remember I said all of them are what? Are positive. Guys, are you still here? Hello?
Yes, we're still here.
Okay, cos and tan. So it's gonna be first quadrant, second quadrant, third, and then fourth. So on the first quadrant, we said the sine it's positive, the cos is also positive, and tan is also positive. Okay, and then on the second quadrant, sine, we said only sine it's positive. Remember, only sine it's positive, but cos and tan, they're gonna be negative on the second quadrant. And then the third one, we said tan, only tan it's positive, which means the sine and the cos are negative. Okay, and then on the fourth one, we said cosine, it's only positive, which means the sine and tan is what? It's gonna be what we call negative. So you guys, you have to remember these signs because we're gonna use them. We are going to use them. The reference angle is the acute angle between the terminal arm and the x-axis. Okay, so we're going to have the reference angles. Remember, we have special angles from 0 to 90, and then I said now we're gonna start to learn from 120 to 330. So I'm gonna show you the reference angle. So these ones are the signs of the quadrant. I said on the quadrant one, all the ratios are positive, and then on the quadrant number 2, only sine it's positive. 3, only tan it's positive. 4, only cosine it's positive. Now moving forward, we're gonna do the reference angle. So before I go further with reference angle, do you have any question under trigonometric so far?
Yes, I wanted to ask. Since you said cost,
Yes.
can I start by A?
Why do you want to start by A?
I don't want to say cost. I want to say all students take coffee.
Okay, it's fine. It's okay.
Okay.
It's okay. As long as why I could say, as long as I should do bulori ukamba ngamini ane the diagram.
All students take coffee.
It's okay as long as you remember that. Okay, A stands for all are positive. It's first quadrant. Okay. And then S, it's second quadrant, sine is positive. And then T is tangent on the third quadrant, which is positive also. And then C for coffee, cosine is positive on the fourth quadrant. As long as you know, okay, when you say all students take coffee, you mean this. Quadrant 1 is positive, quadrant 2 sine is positive. It's okay. It's okay. Do you have any other questions?
No questions.
Okay, we can move forward and then do the reference angles. Do you guys know the reference angles?
Yeah, I think I know some.
Okay. If we have 120, where can we refer? Which angle can we refer to if we have 120 degree?
180.
That's not true.
90.
No.
Oh.
Yes.
And so, I are we not choosing 90, 180?
Okay, what is, wait, before that, what is reference angle?
Reference angle.
I heard Chipua, he said he doesn't know the reference angle, and then Dad said he knows what is
The reference angle. An angle which an angle which changes a trig ratio. An angle which changes a trig ratio.
Okay, you can also say that reference angle is the acute angle between the terminal arm and the x-axis. Okay, so let's say we have these angles. We have this angle, and then we have reference angle. Okay. So let's say we have 120 degree. Okay. So the reference angle for 120, it's gonna be 60. The reason why, when we say sine 120, we get square root of 2. And then when we say sine 60, we also get same thing, we get square root of 2. That's what we're talking about when we say reference angle. When we say sine 135, you get same answer as sine 45. Okay, so reference angle is the acute angle between the terminal arm and x-axis. So if we have 120, we can refer to what? To 60 degree. If we have 135, we can refer to what? To 45 degree. If we have 150, we can refer to what? To 30 degree. So. Okay, and then if we have 210 degree, we can refer to what? To 30 degree. Okay. Do you get this reference angle? Eh?
Yes, but I wanted to ask. Since 150 and 210 have the same reference angle, are they not equal?
Equal how?
Equal. Agree. 150 and 210 are both equals to 30.
Yes.
Can't we equate them?
Yeah, but the sign, they are going to be different. The 151 is going to be positive, and the 210 one is going to be negative. I mean, the 151 is going to be positive, and then the 210 one is going to be a negative. You get? So from the signs. Okay. And the quadrant. So remember, on the quadrant, we have 0. Is it 0 and 90 are here? I think 180 is here. 0, 90, 180, 270, and 360. Okay, so 210, it's gonna be on the third quadrant, right? And then it's gonna be below here. It's gonna be negative. You get? And then 120 is gonna be here, and it's gonna be what? Positive, right? Remember, we said let's use sine. Sine, it's positive on the second quadrant. So if we put sine here, it's going to be a negative. Okay? On the third quadrant. Do you get it?
Yes, we totally get it.
Okay. Yeah, so this what do you call reference angle. So 210 is gonna be we're gonna refer it at 30 degree, and then 225 we're gonna refer it at 45 degree, and then 240 it's gonna be 60 degree. What else? And then 300. Remember, we said we're gonna start from 120 to 330. 300 is also gonna be 60. 315 is gonna be 45, and then the last one, 330, is gonna be 30 degree, like this. Okay, and then let's move forward, and then we're gonna do some examples. So when we're talking about reduction formula, remember we said the topic here is reduction formula. Okay, so on the second quadrant, so this is our first, this is our second. On our second quadrant, reference angle is gonna be 180 degree minus theta on the second quadrant. This one is for second quadrant, okay? So it's gonna be 180 minus theta, and then sine is going to be sine into 180 minus theta, okay, which is the same as what? Same as sine theta. Okay, so this is reduction. When we're talking about reduction, we're talking about this. So on the second quadrant, here we're focusing on the second quadrant. It's quadrant number 2. Okay, so the reference angle is going to be 180 degree minus theta. And then when we're talking about the sine, so it's going to be sine 180 minus theta. When we reduce it, it's going to be what? Sine theta. Okay, sine 180 minus theta. When you reduce it, it's what? It's sine theta. Okay, and
Bobby?
then
Since we're still on the 180. I wanted to ask about the 90. Since if it's 90, is it 90 plus or 90 minus?
yes, we're gonna come to that. Yes, we will do that.
And then sine or cos is gonna change into cos or sine. What?
Yeah, we're gonna do that. We will do that.
Okay, sharp. You may continue.
Okay. So we are doing our second quadrant, and then I said 180 degree minus theta. It's going to be sine theta. And then when we're talking about what we call cosine, we start with sine, and then cosine. And then when you say cos, 180 minus theta, it's going to give you what? A negative cosine. Cos theta, because remember we said on the second quadrant only sine is what? It's positive. That's why here the cos, it has what? It has a negative. Okay, now let's move forward and then do the tangent. Remember we are focusing on the second quadrant. So tan 180 minus theta, it's going to be what? A negative tan theta, because it's what? It's on second quadrant, and then second quadrant we say only sine, it's what? It's positive. It's positive. And now let's use a reference angle on the third quadrant. A third quadrant, 1, 2, 3. On the third quadrant, which ratio we said is positive on the third one? Hello? Chipiwa. On the third quadrant, which ratio did we say it's positive? On the third quadrant, which ratio did we say it's positive?
Tan.
Okay. So now we're gonna focus on the third quadrant, quadrant number 3. Quadrant number 3. So it's gonna be 180 plus theta. This is our reference angle. So sine 180 plus theta. Remember, on the third quadrant, it's only tan, which is positive. So it's going to be a negative sine theta. And then cos 180 plus theta is going to be a negative cos theta. And then tan, that's where it is going to be a positive. Because we said on the third quadrant, tan, it's only positive. The others are what? are negative. And then on the fourth quadrant,
Poppy?
mm-hmm.
No, Satufukisa.
Okay.
Since you said if equally cos 180 minus Zamba ya
Cos
move
180 minus
theta.
mm-hmm.
Does it shift to the actually it's 90, 180, 270, 360.
Mm-hmm.
If it's cos 180 minus, does it shift like 1 point forward?
Does it shift 1 point forward? Remember,
Like if it's like if E180 minus T.
yes.
At 180 ika 1 2 90 ika second na third.
Yes. Mm-hmm.
So yeah, already E180 minus ka fourth.
Ikova apa ya da apa.
Okay, let me just ask like this. Okay, already E sin 180 minus iba
sin 180 minus theta. Actually, either way, it's a second quadrant. And then we know that second quadrant is a positive. And actually, move
like actually, it over equal 180.
Mm-hmm. This is 180.
After 180. Mm-hmm. Yeah. Yes. After 180. I think after 180, the 270.
Yes.
Yes. Okay, E180 minus idoyaka 270.
Iko subtract. Shambori iko dobe kupunguzeya. Shambori idobe kwaga iko ya murao. And then each add idobe iko ya pan.
Zamba arariari.
And the jidoba jiko depend ore ikakwa okay. Atiri kobona 180, wabana 180 minus na wabana 180 plus. And ara rich cos focus aka second quadrant amulori cos iba negative. And then shambori in negative ide kumuvera pasi. And in the positive idoba ihane papa noni. Ka second quadrant. Uko jo faces ajira.
Yeah.
Yeah. So second quadrant lori sign is positive. And then added in a minus jamuri in the bakedan iko punguze ya batuku. Atiri ngapano ni ka second quadrant rina negative na positive here. Rabana negative na negative. Ukobona. So added one negative answer jamuri negative answer iko doba is iya panoni coming ka third quadrant. Already positive, it the way could dera guy, hapanga kawan. Each go shifted and I get it.
Okay.
Okay, and then we were on third quadrant, and then now we're gonna move to fourth quadrant. No, Neta. Eh?
Could you get toilets?
Velo sala 10 minutes ukama ngochpi. And then after we recorder, my voice ale ada kufana. Uri ni kwa toilet.
Let's say Jen.
What was at 9 minutes? So quadrant 4, reference angle is gonna be 360 degree minus theta. And then quadrant 4, 1, 2, 3, 4. And then which ratio is it positive on quadrant 4?
On the ratio which is cos.
Yes. Great. And then sine 360 minus theta is gonna be a negative sine theta. But do you understand?
Because
Because
it's gonna be on the third quadrant.
it's reducing. 360 minus ido ikofunguzela angle ikofunguze. And then cos 360 minus theta. We say cos it's what? It's positive at fourth quadrant. And then tan 360 minus theta is gonna be a negative tan theta. Okay, so we're gonna stop here for today, and then we will have another session on Thursday. But I will also give you activity to do. I'm gonna send you activity to do, then you'll send it back to me and see if you understand what we were doing here. Okay, so we'll see. We'll continue on Thursday.
Hakuna matata.
Bye.
Bye.